2.4 gigahertz band. But now look at the table. What you're seeing here is the 5 gigahertz band is broken up into the Uni 1, Uni 2, Uni 2 extended and Uni 3, and the transmit power and the maximum ERP are different depending on which band you're deploying at. Now the Uni 1 band, very low power, just 50 milliwatts with a maximum ERP of 200 milliwatts, and so that's for indoor environments. And then you go up to the Uni 3 band, where it's actually much higher power level than what you can do in the 2.4 gigahertz band. This allows me to go all the way up to 4 watts, and so this is for outdoor use only. So when you're deploying your access point, you'll choose your spectrum in the 5 gigahertz band, and the maximum power level, the maximum ERP, will differ depending on what frequency you're operating in. So just to show what's possible in an outdoor environment if you're doing a point-to-point, like between two buildings using directional antennas, you can see here I'm using the 3-to-1 rule. I start off here with 30 dBm as my transmit power and a 3 dB antenna, getting to my maximum ERP of 36 dBm. And then as I increase the antenna in chunks of 3 dB, I have to reduce the transmit power by 1 dBm, but you can see I can get up to 52 dBm in terms of the ERP, maximum radiated power. In fact, the maximum ERP that you can get up to in the Uni 3 band is 53 dBm in a point-to-point connection. So just to finish up on the regulations here in the States, the FCC actually banned the use of a standard antenna jack. In other words, if you take your access point and buy an off-the-shelf antenna, you cannot actually connect the two because the connectors will be different. And in the case of Cisco, they use a RPTNC connector, and it's very specific for their antennas and their access points. But the reason they do that is to prevent you using an off-the-shelf antenna and therefore accidentally going over the legal limits that the FCC has defined. So let's now move on to safety regulations. So the first thing you want to do when you get given a site survey is to look at the location and say, are there any specific safety regulations that I need to know about going out to this site and conducting my site survey? It's not uncommon, for instance, in a manufacturing environment when you get out there to be asked to wear a hard hat or maybe even safety earpieces to protect your ears against a large amount of noise. This is particularly true if you're operating in a hospital, manufacturing, mining, refineries, warehousing. Those typically have some sort of safety rules, and there are some sites where you might actually be required to actually go through safety training before you can actually go out and conduct the site survey. So make sure you ask this question before you start the survey. Now, most countries around the world will actually have regulations that define what that safety should be. And in the United States, for instance, they have the OSHA regulation, which again defines what does it mean to create a healthy environment for people to be working. As well as having national standards, there could be industry-specific standards. And one example here, again I'm using the US, is the Mine Safety and Health Administration regulation. So again, there could be regulations for in general across the country that defines the rules for safety. There could also be regulation that's to the specific industry that you're in. And again, mining, refinery, those are typical examples of where you'd find industry-specific safety regulations. And again, do not be afraid to ask. The easiest way to find out is to ask the people who are actually in the industry working at the company that you're going to go out and do the site survey at. I always find the facility manager to be an excellent source of information in this regard. Here in the US, wireless is also regulated in terms of the body absorbing those signals, and that's called the specific absorption rate. And for devices held next to your ear like a cell phone, has a much more stringent requirement than a laptop, which is normally about a foot away from your body as you're typing. And so different radio technologies have different regulations associated with them. Also, there may be some requirements if you're deploying it outside, such as you're putting your access point on top of a radio tower or a roof that's got some restricted areas. And so please bear in mind that when you're dealing outside, especially very tall heights, there may be some other regulations that you need to look for as well. There are also building codes that you need to worry about. So for instance, if you're deploying your access point in a ceiling and that ceiling has got airflow going through it, then your access point needs to be plenium rated, because if it's got airflow going through it and there's a fire, you don't want toxic fumes going into that airflow. Elevators and escalators are a particular area to pay particular attention to. You don't really want to be putting an access point or any cables into a lift shaft, for instance, because that can actually break a lot of building codes. So you really need to look at those regulations if you're deploying, and my advice to you personally is just stay away from elevators and escalators if you can. Sometimes you can't always avoid it, and so you need to look at the regulations. So again, there's other codes when you're deploying outside. There's tower regulations. You may need to put lighting on there if it goes over a certain height because of aircraft, etc. Very unusual to do that with an access point deployment, but you should at least be aware of that. There's also regulations around the National Electrical Code here in North America, making sure that equipment is properly grounded and has lightning protection. There's also, in many countries around the world, including the States, protection about the types of data that's going over the air. And what you're trying to do here is to protect the privacy of the user data. And in particular here in North America, you have to worry about HIPAA, which is protecting patient data. So if you're doing deployments in hospitals, anything around human resources, doctors' offices, take a close look at HIPAA. So now we've looked at the safety regulations, let's take a look at some equipment ratings. Now, the National Electrical Manufacturing Association has come up with a set of definitions that define the protection that a housing can give a device. And so what we're talking about here is the housing that your access point is contained in. Now, you can take an access point and put it in one of these housing, or the access point can be defined to have this type of housing. So it's like an enclosure that's going to protect you against the elements. And you can see here the types of elements, things like falling dirt, dripping and splashing of liquids. So for instance, if you're working in a manufacturing environment, it's quite common to have water, liquids, dust, and so you need to choose the housing appropriately for operating in that environment. So it's not just outdoors where you've got rain and snow, etc., but it's also for the indoor environments such as manufacturing and other locations. And so you want to choose what kind of housing you want depending on the environment that you're working in. Now, to give you an example, this is Cisco's 802.11n outdoor access point, and you'll notice here that it's certified as a 4X. Now, from the previous slide, you would have seen that a 4 enclosure would have protected against rain and snow and sleet, dust, formation of ice, and also hose-directed water. This one here also has certain levels of protection against corrosion. So what I thought for a demonstration would be really interesting to take a look at how you can configure your access point. And earlier on we talked about how you might have to reduce the power level if you're using an external antenna in order to keep underneath the legal limits. There's also some other reasons why you might want to reduce the power level. For instance, if you were supporting VoIP phones. So now we're going to take a look at how do I reduce the power level down on my access point. And you really have two options. The first one is you could connect through the browser interface. And here in this simple configuration, I have just taken the access point, which I'm powering through a PoE, and then I connect another Ethernet cable from my laptop into the PoE, and I access the browser and type in the IP address of the access point. The second demonstration, I'm actually going to do the same thing, but I'm going to use the command line interface. And in this case, I'm going to connect my laptop with a serial cable into the access point console port. So let's start with the browser interface. I'm going to bring up Firefox, and I'm going to key in the IP address of the access point. And I'm going to log in to the access point using the default login, Cisco and Cisco. So here you can see that I'm logging in to an 1140 series access point, which is a dual mode 802.11n access point. In this configuration, I set it up using the Express setup. And here you can see it's got the default host name, and here you can see where I assigned it an IP address. I also used the Express security setup. So here you can see that I can give it an SSID name. So I'll call this Avrils AP. And I can set it to broadcast the SSID in the beacon, which can be quite useful later on in the survey if I have any issues detecting this particular access point. Notice here I've set it up with no security, and of course this isn't connecting to a live network, and so there's no reason for me to put security onto this access point. I'm going to come down and click Apply. Okay. So now what I want to do is I want to go into the radio settings and change the transmit power. And to do that, I need to go into Network Interfaces. Notice here that there is two radios. This is a dual mode radio. So there's 802.11n at the 2.4 gigahertz band, and then similarly 802.11n at the 5 gigahertz band. And I need to configure both. So let's start with the 2.4 gigahertz radio. And what I want to do, I want to go into Settings. And here you can see that the radio has been enabled and it's been set up as an access point. And so this is a point to multi-point deployment. If I wanted to do a point-to-point, then I could come down here and set it up as a bridge connection. Now if we scroll down and take a look at the data, here you can see the modulation and coding schemes, and so you can see which ones have been enabled on this access point. And if I come down a little bit further, you can see the settings that I want to change. And you can see here is the transmit power. And this is what I want to change, and it's currently set to 17 dBm. Now, what Cisco actually provide is this translation table, which is quite useful. So quite often you may be wanting to set your power, and you may know that power in milliwatts, but not know what the dBms are. Now, personally, when I do a site survey, I always carry a calculator.